Hey everyone, welcome back to this session and here we will discuss a question on IBDP MAA HL paper 1. GDC is not allowed for this question. Okay. So the question says, consider this complex number z is equals to 3 raised to the power iota minus 1. So we have a complex number over here and first part says write the integer 3 in form of e raised to the power a where a belongs to a real number. So basically we will use the property of logarithm which says if we have something e raised to the power of ln x, this value is same as x. So yes, here we have to write our 3 number in terms of this e raised to the power a. So now can you use it? Yes. 3 will become equals to e raised to the power ln of 3 only. So from here we can compare with the given expression e raised to the power a. So can I say the a value must be this power part which is ln 3. That's the answer for the first one. Okay. Now, second one is, it says, hence, giving your answer in form of this p cosine log of q, where p and q belongs to some positive rational numbers, find the real part of z and find the real part of 1 over z. Basically, if we have any complex number z equals to, say, r e raised to the power iota theta, then we can simplify it by writing r e to the power iota theta can be written as cosine theta plus iota sine theta. The part which have iota in it is imaginary part and part without iota is the real part. So from here I can say z equals r cosine theta plus r, or you can say iota r sine theta. Here this r cosine theta is the real part. Real part of z is r cosine theta and the imaginary part of the same complex number is r sine theta. So in this way we can use this Euler's formula to convert this exponential form to standard form and compare the iota part and constant part. Okay. So first it says giving your answer in this form of p cosine log q. Find the real part of z. So what is z? We already have the complex number z value. Z is equals to 3 raised to the power iota minus 1, right? And we have already seen in the part A that we can write this 3 as e raised to the log 3. So let's rewrite it. So we get z equals e raised to the power log 3 times iota minus 1. Okay. Then we can also write it as one more thing. We can also rewrite this first one as 3 raised to the power iota times 3 raised to the power minus 1. That gives 1 over 3 for the 3 raised to the power minus 1 part and 3 raised to the power iota part. Okay. So now in the next step, let's write 1 by 3 times, in place of 3, I will write that e raised to the power natural log of 3 times what? Iota power iota. I'm just replacing this 3 with that e raised to the power a part. Okay. So that gives me 1 over 3 times e raised to the power iota times natural log of 3. So this natural log of 3 is our theta. Now you can compare it with our r e raised to the power iota theta part, right? So here r is 1 over 3 and theta is ln 3. Directly also you can compare it and get the answers by the way. But okay, if you want to simplify it further, you can simplify it. Like z equals 1 over 3. Now it will become cosine of natural log of 3, which is our theta value, natural log of 3, plus iota sine natural log of 3. Now as it says, find the real part only. Okay. So we have to find the real part of this. So real part of the complex number z comes out as 1 over 3 as it is cosine natural log of 3. That is it. This is the answer for the first part. So real part of z we got already in this form. So we can say p is 1 over 3 and q value is 3. Okay. So real part done. Now second part, it says real part of 1 over z. So for that we need to find the 1 over z value. Okay. So let's simplify it further. We have the value of z as this one. So let's find the 1 over z value. in the next line. So I have 1 over z as what? 3 raised to the, you can take the reciprocal of this only. Okay. So that gives me z is equals to 3 raised to the power 1 minus iota. That is also same as 3 times 3 raised to the power negative iota. That can also be rewritten as 3, then again replacing this 3 with that e raised to the power natural log of 3, then negative sign as it is iota. So now here we got our theta as this negative natural log of 3. Use the same. So we got 1 upon z equals 3 as it is, cosine of theta, which is negative natural log 3, and then plus iota sine negative natural log of 3, right? So I'm just replacing my theta value. This is theta, okay, natural log of 3. Negative natural log of 3 is the theta value over here. And I'm using this definition, Euler's formula, that e to the power iota theta is cosine theta plus iota sine theta. Okay. Now, on simplifying it further, we got the 1 over z value, or we have to find its real part only. So let's directly find real part of 1 over z. That comes out as 3, as it is only the part without iota. So what is that? Cosine natural log of 3. And I'll write this, it will become natural log of 3 only. Why? Because cosine of negative theta is same as cosine theta. It gulfs the negative sign. Okay. But if you have sine of negative theta, that becomes negative sine theta. These are the properties of trigonometric functions. So here we have cosine theta. So that's our answer for this question. Okay. I hope you got this. If you still have any confusion, you can ask me your doubt in the comment box. Okay. Or you can connect with us using the number given on the screen. Thank you for watching this. See you in the next part. Keep watching, keep learning.